Okay, so this will be our final talk for the JuliaHealth mini symposium today. And this is, we'll go ahead and get started in just a second. All right, so we'll go ahead and get started. So thank you everyone who is able to make it, who is able to join. This is the RAG-LLM workflow for observational health research using JuliaHealth LLM. Again, this is work done by Param Thakkar. He was unable to make it as well, but again, I wanted to emphasize and share the work that he's been really pursuing in bringing the JuliaHealth ecosystem to the world of large language model design and utilization. This is Param. He is based in Mumbai, India, and this work that we're talking about is mostly driven by him, so a huge thank you to his work. With that being said, let's go ahead and dive into the background and the rest of this talk. So what is the background here? Well, the background, just to give a quick overview, large language models, we all know, or at least are aware of them. And as we know that large language models are AI systems trained on vast amounts of text data to understand, generate, and reason with human language. They're built on top of transformer architecture and has multiple different key features. But I think the most applicable or understandable feature that we know about is things like chatbots like ChatGPT, DALL-E, and a couple other code generation tools like Claude Code, for example. There can be multiple different problems with these LLM-based approaches, which we'll talk about, such as hallucination or generating biased sort of content. And just an example, here's kind of your garden variety of different sorts of large language models being used in the world right now. So moving on from there, so as you all know, so JuliaHealth kind of has this goal of being an open source community and initiative focused on applying the Julia programming language to advance medicine, healthcare, and biomedical research. It brings together developers, researchers, clinicians to build high-performance, scalable, composable tools to accelerate innovation in the health and life sciences. So you might wonder, why combine JuliaHealth with LLMs, this sort of technology that can be very biased, that can be very inaccurate, and potentially lead to potential harms? So let's talk a little bit about that and what we tried to achieve here with our project. So the idea is that in JuliaHealth, and a lot of constrained workflows that we can talk about, is sometimes they can be very manual, time-consuming workflows within exploratory data analysis, be it writing handwritten SQL queries, or other sorts of technical sort of explorations that require a lot of domain expertise if you want to do a small proof of concept. Large language models, as we know, can generate complex queries from plain English, could help in the sense of building patient groups without coding in a JuliaHealth setting, and use feedback to adjust queries and definitions within a JuliaHealth workflow, especially built around observational health or other sorts of research endeavors. The idea here is that this could be faster, more scalable, accessible to non-experts, while also preserving and being conscientious of potential biases that can arise in this sort of ecosystem process. So to give an example, this is what some parts of the world have done. So this is a product out of the Observational Health Data Sciences and Informatics Consortium called the Query Library. And if you see here, there are a variety of different queries that have been handwritten over time. This is mostly a query library that I think has been built over a decade that encode very painstakingly queries people have written to address certain problems that they're interested in, such as conditions stratified by age, group, age, race, and gender, things like that, so on and so forth. And the idea here is to potentially use this sort of large language model generation tool to train upon these sort of queries that have been written over time, and to target things like data models that use observational health data, like claims or electronic health records, in particular to enable reproducible sort of data analysis pipelines using RAG-based architecture. And the idea also is that this could lay the foundation for scalable AI tools in general for JuliaHealth and provide kind of the first pass or the first entry point for the potential that LLMs could have in a JuliaHealth workflow or environment. So to talk briefly about the methodology, is that in the methodology, there's a variety of different tools that we're using here, as well as data sources. For example, within the different knowledge sources that we're using the Book of Odyssey, which contains guides to methods and tools for observational health research, the FunSQL documentation, which provides documentation for a Julia library used in medical data querying, amongst other sort of data visualization, data analysis tooling. and the OMOP CDM schema description, which provides a standard structure for organizing health data. So taking all this different sort of knowledge information, we've actually built a RAG-based or PG vector-based, I should rephrase that. We built a vector-based database using PG vector that chunks up and indexes all this different sort of information coming from these different sources using the Julia package simpleindexer.jl and also drwatson.jl to maintain and work with our study that we're doing here. So Param has been really ambitious and really productive with determining how large language models can be used in JuliaHealth, such as actually developing a training corpus on Hugging Face itself. So if you want to use the data, we'll show a link to this in just a moment. But here we've been able to actually build our own data set of FunSQL queries based on real-world clinical query examples using things like the query library as a reference, which is available under open source licensing. We're using different data sources, and now we're actually in the process right now of standing up and setting up our own configuration testing harness to validate these sort of generated SQL queries that are coming off of the JuliaHealth LLM and investigating how they actually work in real time against an actual synthetic patient database. So shown here, kind of a little blurry, my apologies, is our first ever kind of like FunSQL Hugging Face library that we have on Hugging Face. So JuliaHealth actually now has a Hugging Face presence. So if you are using Hugging Face and want to be hosting data sources or other tools here, please let me know. Happy to get you hooked up with this. As we do qualify as an open source org, we do get a couple different benefits. But this is just our first kind of pass at creating a data set where we have, for example, a concept, we have a query, we have the plain text description, the SQL query that is being written, and then also not shown is the FunSQL translation to be used as a training data set. So to speak about what other tools we're using within the Julia ecosystem is some core Julia Gen AI tools such as prompting tools, RAG tools that come directly from Julia Gen AI. And then to speak to data embedding and storage, we use File Chunker. The particular model that we've been exploring is Nomic Embed Text version 1.5. And then as mentioned earlier, we're using things like libpq and pgvector to actually create from within Julia an indexed vector database for future large language model work and research. So to kind of give a quick and dirty kind of where we're at with things right now with the project is that we do actually have a full working prototype that exists within the JuliaHealth LLM repo. There's actually 2 repos. We'll probably rename one to be less confusing. But the first repo actually contains the material that we want to use for the RAG architecture, whereas JuliaHealth LLM.jl contains convenience tools and other things specific to the JuliaHealth ecosystem that can help you develop a local first based large language model RAG architecture setup. So shown on the right is actually a query that was generated using one of these local large language models on my computer using the tools that we've built so far with JuliaHealth LLM. So as you can see, it kind of does a lot of reasoning and spits out at the end what it thinks is the correct answer. Spoiler alert, unfortunately, that is completely wrong. We are working on revising and optimizing sort of these queries at the moment due to the fact that while we have the tools in place, there is still much room on the table for improvements to be done, such as thinking around Julia's strengths. Julia is great for high performance and well suited for domain specific tasks. But unfortunately right now, things like fine tuning, APIs to work with different sorts of LLMs, it's unfortunately quite lacking. So we're working around those barriers right now as we speak to optimize and make these sort of pipelines even better within the Julia ecosystem. And as I mentioned, there's different ways we can improve RAG accuracy and curation around what we actually are putting into our RAG-based architecture. And the final thing that I want to mention is that we're also very much considering exploring safety guardrails around the different sorts of applications taking place. I want to highlight in specifically NVIDIA NeMo guardrails, which comes from NVIDIA, which is their kind of cutting edge research into guardrail technology. And the whole reason why we care about guardrails is that we want to look at how we can ensure safe and accurate LLM language outputs, especially if we're looking at health-related sort of concerns and health-related problems here. And in NVIDIA NeMo actually operates as a server client such that we could write a Julia wrapper around this, house this within the Julia Gen AI ecosystem, and still bring the work being done in guardrail and AI safety and surveillance safeguarding technologies to the Julia landscape and ecosystem. So that's a bit of a high-level rough overview of what we're looking at for JuliaHealth LLM, how we're thinking about approaching bringing large language models into the JuliaHealth ecosystem, and how we can continue to grow and look at opportunities here with this emerging technology. So thank you all so much for your time, and happy to take any questions. And again, this is the majority done by Param Thakkar, so if you want to reach out to him, he will be the person that could answer more questions if you have them. Thank you. I think we're actually mostly all done for the day, so that's the end of the JuliaHealth mini symposium. So if there is any additional questions, we can float around. Otherwise, that is it. So thank you for the first ever JuliaHealth mini symposium, everyone.